Hi, in this video I will show you how to set up Arduino device example. For the purpose of demonstration, I will use basic LED example. As you can see in reference, there are two libraries meant for Arduino environment. Wi-Fi gate device for boards using onboard Wi-Fi like ESP family or Raspberry Pico W, and serial gate device for projects where the board will be connected to host device by USB cable. In this tutorial, I will focus mostly on Wi-Fi gate device library, but I will show you as well that there is no significant difference in library usage between Wi-Fi gate device and serial gate device, so most of what I will present is valid regardless of library you will use. If you want to connect your boards with USB, there is another video that shows how to use GateHub for this purpose. So let's start from setting up Arduino IDE. What I will be doing is described on project page in Arduino section of reference. First, I'm moving to download section and download what I need. I will install both libraries at once, but if you're not planning to use one of them, you can just install what you need. Let's include the libraries into Arduino IDE. I'm clicking Sketch, Include Library, Add Zip Library, browse to Downloads folder and select Wi-Fi gate device package. I will repeat these steps to include serial gate device as well. Cool, library is installed. As mentioned in reference for Arduino, Wi-Fi gate device library requires WebSockets library to work properly, so now I will open Library Manager and type WebSockets in search field. As you can see, there are several search results. What we need is WebSockets library by Marcus Sattler, so make sure you are installing exactly this one. Great, now we are all set. Let's proceed to the example. I go to File, Examples, scroll down to Custom Libraries section and open Basic LED example from Wi-Fi gate device library. Please note one thing. If you open the same example from serial gate device library, you will see that the code is nearly identical. The only difference is within include statement and the way device object is created. It is so because both libraries are built on top of an abstract base device class. So if one day you will like to switch between libraries, you don't need to modify your code except the two lines I just mentioned. Let's stick to Wi-Fi example for now. On top of each example, you can find some information about it. Here you can see that this example is ready to use with Raspberry Pico W. For the purpose of demonstration, I will use Node MCU, which is basically a dev board for ESP8266 module, so I need to do some adjustments. Different board families need specific Wi-Fi library to handle Wi-Fi connection. Raspberry Pico, for instance, comes with its own Wi-Fi library that is already included. That's why original code don't need any additional include statement. My board is effectively ESP8266 module, so I need to uncomment this line. Also, pin numbering is board specific. According to Node MCU documentation, my pin will be D1 this time. Obviously, I need to update Wi-Fi credentials as well. Good, example is ready. Let's have a quick look on what's going on in the code before we upload it to the board. As written in the description, example demonstrates remote control over LED brightness. So first we declare a variable that will hold number of pin our LED is connected to, create device object giving it desired network credentials, and use createInt factory method to create gate value of integer type that will hold LED brightness setting and synchronize it whenever other system components would change it. Note that there are also other value types available. You can check device section of reference to read more. We declare the value as input, which means we allow the value to be modified externally. If we would like our value to be read-only within the system, for example, if it would represent current temperature or other sensor reading, we could declare it as output. All we need is declared. Let's move to setup block. We set our LED pin as output, set device name and value name. It will be displayed in user interface. Naming devices and values is optional, so if you don't need this information, you can omit it. We set our value range to what is acceptable by analog write method. This is also optional, but in this case I know precisely the range, so it's convenient to do so. Finally, I assign callback that will be invoked every time something would modify my value externally. Below I declared a method containing logic to handle such event. In this example, it's just writing current value to LED pin. As last step, I start my device to let it do the magic. Within loop block, I just invoke device loop method so it can do its stuff. Okay, we know what's going on in the code. Now we can upload it to the board. Let's wait a moment. Sketch uploaded. Let's have a look on user interface. Great, device have joined the system. Sometimes it might happen that you will need to restart your board manually after uploading a program. So if your device is not joining, try restart first. Now the moment of truth. Is it working? Fortunately yes, I can control the LED from web browser in my phone. That concludes the demonstration. Hope it's been useful. If you have any thoughts that you would like to share with us, just leave a comment under this video. Thanks for watching and see you on other videos.